Thank you, thank you. Welcome everyone. Welcome to today's talk about AWS IAM policy. My name is Rafikul Sekh. I am a software engineer at Ashurian. Before I start, how many of you have worked with AWS services? Awesome, I got the right audience. How many of you have worked with AWS IAM policies? Awesome, great. So today, in today's content, I have a few content which is for beginner or who don't know much about AWS IAM policies. And there are few content which are going really deep. So I put it in such a way that it will be easier for anyone to understand. So please bear with me on my presentation. Let's start without further ado. Let's look at today's agenda first. Oops, sorry, somehow my slide is not working. All right. First, we are going to discuss why we need IAM policy. After that, we are going to learn about the JSON document structure of IAM policy. Then we are going to learn 3 types of IAM policy: AWS managed, customer managed, and inline. After that, we are going to learn some other types of policy, which are also IAM policy, but it has different purpose. Once we learn all of those policy, then we'll learn how they all work together to contribute on policy evaluation logic. After that, we are going to learn when to use which type of policy, and then we will troubleshoot one authorization error. Then finally, we will learn how to achieve the least privilege. First of all, how will you secure this app? We have 3 types of user: content viewer, content writer, and admin. So content viewer should not be able to modify anything in the app, and content viewer can modify and view. Admin can do all of the things, plus it can modify user, add role, or so many things. Now, if I think how I will create, first I will think about the login or authentication and authorization, so that I can identify using the login who is trying to access my app. Once I identify that, then I will try to identify, okay, what kind of role this user has. Based on that, I will give access to the application. Now I did the application, and one content viewer user is trying to access the admin URL. Somehow they know what is the admin URL and they are trying to access. So my authentication is passing because that user is a valid user, but authorization, he will be failing because this user does not have admin role. Instead, it has content viewer role. So we'll not be able to see the page. That's good. Now the admin user is trying to access the same URL. Authentication will be successful. Authorization will be successful because of the admin, and we'll be able to see the page. Everything is going good till now. Meanwhile, the content viewer user was playing with the app and suddenly found out that he is able to modify something in the cookie and able to gain access as admin. That's not good at all. And this can happen to our AWS account, and this authorization part is done by IAM policies. So that's why we are trying to learn today. Now let me demonstrate something about this. So I am going to one issue2 instance. Let me see if the issue2 instance is up now. First, I will go inside the issue2 box with a role. Let me check this role. So this issue2 instance has this particular role. And in this role, I have given S3 read-only permission, and I have added one assume policy so that this particular role can assume some other role related to people who already know about this can understand what is going wrong, but can assume another role and then maybe read some data from DynamoDB. So that is the purpose I have added this one. Now let's log in into issue2 instance. Let me go back to issue2 and grab the connection from here. So if I right click, I will get the connection string. I think it is visible. Okay, I'm inside the issue2 box now. I have some command ready. I'm going to run on that. So first I'm going to do S3 ls to see if S3 permission is there or not. It should be there. That's good. Now this user is trying to do something in IAM, trying to see another user's profile. It should not have access. So that's why you can see that access is denied. But somehow this user is able to understand that there is another role and can assume that role. So is trying to assume a different role now. Okay, so assumed a different role and successfully got the credential. Now let me update the credential on my text here. So got the full access basically. I have given a role which has full access to my account and got it. So yeah, it can do anything now in my account. Now let me update the session token. So now let me execute the same command that I was trying to execute before. First, I'm trying to list something from S3. Yes, I have permission. Also, now let me check if I have IAM permission now. Yes, I have IAM permission. So you can see how things can get really out of hand and they can get complete access for our account. Just doing one silly mistake. I am a developer and I just did one small mistake in the policy and account is out of my control now. So let me revoke the access first. So I'm going to IAM and going to that full access role. I'm trying to revoke this session. Okay, once I revoke, now the access should be gone. One more try. Sometime it cached. Okay, good. So the access is now denied. Now let me go back to the presentation. So here. So we saw in EC2 console how things can go wrong by doing something wrong in IAM policy. Now let's look at one AWS account, how actually authentication and authorization works there. Suppose I want to access one file from S3 and I can give the request from CLI or from console. Once I give the request, first AWS verify or authenticate that request and try to identify who is the principal. Principal means the user or role or federated user or the application who is trying to access. Once AWS have that, then AWS can give that information to the request context. In the request context, it has the action name, the resource, this principal, and some other related environment variables. And based on that, it pulls all the policy document related to this particular request context. And based on those policy document, AWS authorized that particular request, either allow or deny. So today our goal is to learn how this authorization work internally, and we'll learn that in depth today. So once, if it is allowed, I will be able to execute this action, otherwise it will be denied. This is one example of policy document. So for people who didn't work with AWS much or IAM, this is one JSON document. And with that JSON document, we can give those permissions. It has this particular structure we need to follow. JSON document is just a key value pair. So first we need to mention the version. Version is the policy language version. And it could be either 2012-1017, which is the current version, or older version was 2008. If you are working with some older policies, try to update with the newer one. And ID, which is an optional field, but if we mention ID, then try to be unique on that. Statement is the required field, and this is the main part of our policy document. Inside this statement, we can have multiple statements. You can see that curly brace in bold, that is one particular statement. We can have multiple like that inside this array. And let's look at how one statement looks like. So one statement could have one SID, that is the statement ID. Normally, if we give any statement ID, it should be unique within this policy document. And then effect, which is allow or deny. Then principal, it could be either the user or role or federated user or service. And we can specify the ARN of that. ARN means Amazon resource name. And few example of principals are the account. We can specify the full ARN of the account or just the account number. Also, we can specify principal like this, the username or federated user or a role. Also, it could be anonymous user. Next is action. Within this action, we can give either one array of actions or one single action. In this example, I have just given one single action. In this action, it has two parts. There is a colon in between. The first part is the service identifier, and the second part is the action we are going to do against this service. Here are some example of actions. The next is resource, where we can specify the ARN of particular resource against which we are going to execute this action. It could be a bucket or some EC2 instance or some other resource. The next is condition, which is an optional field. With condition, we can make a policy very specific and achieve least privilege very quickly. So in the condition, we have first condition operator, then after that operator, we have a key value pair. For example, we can say condition string equals username is John Doe. So string equals is the operator and username is the key and John Doe is the value. And we can specify the value as an array. When we specify the value as an array, then all those values are OR condition. Either one of the value is true means that particular condition is true. Now, if we mention two different key like S3 location, then there is another key I mentioned. In that case, it will be AND operation. If I mention two different conditions, then also it will be AND operation. Now, let's look at three more things. As I mentioned, this policy, this particular statement has principal, action, resource, and condition. It follows the PERC model. This principal also could be not principal, action could be not action, and resource could be not resource. What does that mean? Not principal, if you look at this particular policy document, it is telling that give full access for S3 for this particular bucket. Sorry, not access, deny everything from this particular bucket when the principal is not these two, means other than these two principal, all other principal will be denied. So this is very powerful. Same for not action. This is also handy when you need to give access for a lot of different services, but you want to exclude only one or two. You can use not action in that case. I will show later in one of document. Then not resource as the name mentioned, when the resource is not this particular one. So now let's do a demo of three types of AWS policy: AWS manage, customer manage, and inline. I'm going to console. So in console in Firefox, I am right now admin. I'm going to IAM. So if you go to IAM, we have a dashboard here. It gives little overview what we have in this account. Then we have groups where we can create a group and attach many policies in that group. And then we can give that particular group to users. So one group can be shared among many users and one user can have multiple groups. So user and role, they are basically the principal using which we log in. So we log in into our account either using username password, that is the user, or we can federate or we can assume another role, that is this role. So these two principles we will use too much today in our presentation. And next is policies. So policies are the document that I just showed, that kind of JSON document. And those policies we will attach to user or role to give permission or deny permission. Now here in this particular policy tab, all those policies we have are managed policies. What does that mean? Like those policies can be changed and updated. So there will be new versions on that. Even we could have a previous version of that. And those all are standalone policies, like they have its own ARN. If I go to this policy filter, I have customer manage and AWS manage. Let's first see what is AWS manage policy. You can see this little icon, those all are AWS manage policy. I am going to one of the policy called power user. So let's go to job function. Okay. So this power user policy has two statements. First statement is giving allow for all actions in my account except these three. So the not action is in picture here. Then the second one is giving some other action also. So this particular policy is managed by AWS and it has ARN like this. You cannot see an account number in this ARN. And when AWS can update those policies and there is a version. So you can see those policy versions. You can see one policy where AWS has lots of versions. Let me open that. You can see this security audit. Oops, I got logged out, sorry. Okay, good, I'm back. So in this particular policy, we have so many versions. Now let's go to customer managed policies. So I have created some customer managed policies here. Let me show you one of them. I have given some permission in that. Let me create a new customer managed policy. So in order to create a customer managed policy, I will create, then I will say, I want to give S3 read-only access. So I will select list and read, and I can specify for all resources, and then I can see the JSON document here and update directly here also. Then I will select a review policy. I have to give a name, S3 read-only demo. Okay. So once I create that policy, it should be available here in this particular customer managed policies. And we can see the policy document here. It has created one version here. Now, also we have this particular ARN, and we can specify this policy using this particular ARN. Now, if I change something in this particular policy, say I change this name to something read access S3 and review. So there is a checkbox that save as default, or I can uncheck this. By default, it is always checked. So if I do that, it gives me a message here. And what happened in the policy version, still the previous policy is in effect. So I can see that that change I did is not affecting here. So I can just select this and just do set as default. Now it got changed. So now for customer managed policy, if you change something and then say something happened, like your production got broken, user is telling that, then you can just go back and change the policy version back to the previous one and save very quickly using that. So this is how managed policies works. Now let me go to one particular role. This one is NashJS A1 demo. I'm going to attach those policies, and I want to show what will be the effect once we attach that. I have logged in as A1 dev user. Now I'm trying to switch a role. I'm going to select this particular role. I'm assuming that particular role. And in that role, there is no access. So now I will go and attach some policies here. So let me give first admin access. If I do that and go back here, now I should have access for everything. Okay, attaching the demo. So let me refresh this. Yeah, I have access for S3, then I should access for IAM. So all the service access I have. And the same particular AWS managed policy I can attach in any role. Now let me remove this and try to attach some other user managed policies that I just created. I'm going to attach now S3 read-only permission. And if I attach that, this particular user will lose access for IAM. And we'll have S3 read-only access. I can go to S3, but I cannot delete anything over there. I can see everything, but I cannot delete. If I try to delete, it should deny me. So I got one error. Okay. Now let's go back and change, remove this policy and try to add one inline policy. So now I'm trying to give some issue to access, issue to read-only access. I have to select this, all resources. issue to read on. Oh yeah, sure. I'm going to download that after some time and we'll show you. So once I add that, now if I go to this particular user, I lost access for S3, but if I go to issue2, I can see instances over there, but I won't be able to stop this instance because I have read-only access. So later in our presentation, we are going to learn what this particular authorization error is telling. This is not readable at all. Let's go back to presentation. So we learned about 3 types of policies: AWS manage, customer manage, and inline. Now, let's learn about different types of policy. So we have IAM policy, resource-based policy, and ACLs. Those are permissive policies. ACL is a little bit different than JSON document. It is XML-based policy, whereas IAM policy, resource policy, and some other policies, those are JSON-based policies. Today, our main focus will be to learn those restrictive policies. So using those restrictive policies, we can stop any impact in our application. Remember, before some time when I gave full access to my EC2 instance, actually I added some permission boundary so that nothing wrong will happen. I'll show what is permission boundary means. Permission boundary is a managed policy. It could be either AWS manage or customer manage policy. And we can attach that particular policy, IAM policy, to a role or user. Once we attach that, that particular user or role have that specified maximum permission. What does that mean? Like we are putting a guardrail or a boundary. Beyond that, this user cannot do anything. Now let's go and see for this particular role where we have attached a permission boundary policy, which is a customer managed policy where we have just S3 read-only access. And also I have attached another IAM policy as a permission where I have given admin permission. But this user will not get the admin permission. We'll get whatever is in the intersection of permission boundary and identity-based policy. So what will be the usage of permission boundary? Why we need that? For instance, say we have one EC2 instance and our admin want to trust me as a developer and want to give me permission to create a role. But the admin will be sure that even if admin is giving me permission for do that, there will be no harm for my EC2 instance. I'm not going to give some permission and that will not create any problem. So what admin will do, admin will create a permission boundary policy. Then after that, admin is going to update my particular role or policy, role or user that I use for login to the application so that I can create another role, and then admin will give another permission for me so that I can pass that role to the EC2 instance. But when I will create the role, admin will restrict me to use this permission boundary. So if I use the permission boundary then and attach that role to EC2, then even if after some days another developer came and then attached some unnecessary permission there, nothing wrong will happen. So that's how permission boundary works. And the maximum permission will be within that boundary. Now let's go to EC2 console, AWS console and show you what is permission boundary. I have a role here where I have given admin access. Now, if I go back here and I assume that role, I should have full access. I can see EC2, CloudTrail. I can do anything now here in this account. But if I go back and I just set a permission boundary here, say I want to give that customer managed policy we just created, let's add that. This is the one we just created. So if I add that, so I set a boundary here. Now this user should have permission for CloudTrail or should not? Should not have, because we just gave S3 read-only access in permission boundary. And it will not have any other access other than S3. When I will attach the permission boundary, change the permission boundary to CloudTrail. Say I'm giving CloudTrail full access. In that case, this user or this role will lose access from S3. Okay, it has some read-only access because this particular folder is related to that CloudTrail and I have given CloudTrail full access. But it won't have some other access like EC2. It won't have access. But in CloudTrail, I have full access. And I can go to CloudTrail and see the CloudTrail there. I can create a trail, maybe, okay. Already a trail is there. And I can turn off the CloudTrail. Is that a good idea? Okay, let me turn off. It's not good. Okay, we'll fix this later. We'll come back and fix this so that no one can turn off our CloudTrail. All right, so we have seen that what we can do with the permission boundary, we can restrict a user with a particular permission we are giving. Now let's learn about another policy where we can restrict similar way. That is called organization service control policy. First of all, organizations is a service where we can organize many accounts and then apply some policy centrally that will be affected to all the accounts and we can manage them very easily. Let me see what organization meaning. Organization is an account management service where we do centralized management of all AWS account. We can consolidate the billing, hierarchical grouping of our accounts for different reasons, and mainly control over the AWS services and API actions that each account can access. That's what we are going to learn today. How we are going to control. Basically, in organizations, we can apply some kind of policy. So first, give me an overview of organization, how we will do. We will go to one account and then we will make that is our root account. We'll go to organizations and then from there, we can create new accounts or we can send invite to existing account, then they will join in our account, in that particular root account. We can create a hierarchical structure of organizational unit and then we can apply policies either on the root level or this particular organizational unit or this one or directly to the account. Once we apply that policy, that particular account will be restricted to that. Now, we can attach allow and deny. By default, when we create organizations, for all those OUs, it will be allow all services and all actions will be added to them. And we need to have at least one service control policy attached to those OUs or accounts. If we add one deny permission, say we want to deny S3. I don't know if I will deny S3, but I'm just telling if we want to deny S3 and we attach it in the root, all those accounts will not have access for S3. If we want to allow some services, say we are allowing few services in root and few services in product, in that case, the allow from root will not go to the next level. Like you need to have the same allow in all the levels, otherwise you will not get the allow. Okay, let me go and show in a diagram how the effective allow works. So we have A, B, C, and D, those 4 policies, allow policies in the root. And there is one child OU, which is a parent of my account. It has C, D, E, F, G allow. So the effective allow will be the intersection of them. So only C and D will be allowed to my account. And in case of deny, if we add deny anywhere in the chain, it will be denied. Like if I apply in the root, it will be. But if I apply in a particular OU, only those OU's child and child account will be affected, not the other one. So in SCP, it is another IAM policy, but it is a subset of that. We don't have pull everything in SCP. What we can do, we can write statement, SID, effect, and action for allow or deny, but not action, resource, and conditions are only for deny statement. Now let's do a demo of organizations. So yeah, that's a good question. The question is, if we attach a deny policy at the root level, is the root account also get locked? No. That is how they made, like root account will not get affected. All those accounts will be affected. Good question. So let's go to organizations. I have created on org, I have a root where I have attached some service control policy. This is, sure. So service control policy is to maintain your account. Say you have 100 services, but you want to only allow 50 services to be used in your account. So you will give access to only those 50 services so that no one in your organization will use the other 50 services that you have not approved. Basically, it is restricting, and it will be definitely you need to give allow in order to consume or use that particular service, right? So it is just a guardrail. Okay. Okay. Uh-huh. Actually, okay. I see, I see. So you are telling that the principal who is trying to access belongs to another account. That's a good point, yes. So how AWS, I'm actually going to that in a particular slide where I will show how AWS think that which policy is applicable for that. And there I will show that. Actually, this is really good question. I will show you there. Awesome. So let's move ahead. In this root, I have attached few policies here. By default, when I create any organization, I have this full access policy attached to it. Let me show you what is that meaning, full access policy. So full access policy has a star action and star resource allow. And I cannot change this full access policy. This is managed by AWS. You can see one ARN here where I don't have any account number. All other policies I have created here are created by me, and those are like customer managed policies. Now, if I go back here, I have attached few more policies here. Now let me go to the next level and see what they have. So I have just attached one policy here, full access. Also in org A, I have attached only full access. Now, let me go to org A and attach deny S3. In that case, that if I deny here in org A and I come back here, let me grab a full access permission. But S3 is denied. This particular user has full access. Even let me go to admin role. S3 is denied for this account. However, for this B account, I have another tab. For this B account, S3 should not be denied because that is part of another org. Now, let me go and show about that diagram I showed, how the intersection works. Let me show about that. So I have one particular policy which gives allow to few services. I will add that in this level, in this NashJS demo org level. This one is allow EC2 and IAM. Then I'm going to detach this particular policy. So in my root level, I have full access. In this particular org level, I have only access for EC2 and IAM. And this level also, I have full access. I have this full AWS access attached to that. Let me remove this deny access from here. So the effective permission will be the intersection of that. Since I have attached that allow statement here, only two particular services. Here I cannot access something else other than that. I cannot access CloudTrail, but I should be able to access IAM because that's what we allowed there. We have not allowed everything there. Now let me show you some other policies here, what we can do. Remember when I stopped the CloudTrail, I was telling there should be a way I should stop this. Now there is a policy which can protect our account. If we apply this in the root level, then that would not have happened. Let me attach in this root level and see what will happen after. So I'm going to attach deny CloudTrail stopping and going back here in the CloudTrail. Looks like I have not removed that permission yet from there. So in org, in this level, I have not attached the full permission policy. Let me attach this. And I don't need any more. Now, this particular user has full access. I'm going to this trail and trying to stop now. So it is denying me from stopping this CloudTrail. Even I cannot change, I cannot delete. So this account is protected from by just giving one particular policy in the root level. All our accounts in the organization is protected now. Now let's go back to the presentation and move to the next thing. Also, we could write something like this, that when we want to just allow creating resource or using resource from one particular region, or one or two, we can specify this as an array, so it will be OR operation. If we specify this particular condition, we will be restricting to that particular region. Now, if I go back to the presentation, and here you can see I am selecting North Virginia. And if I go to issue 2, I can see all the resources over there. But if I change this to Ohio, then I'm not authorized because I have attached that particular policy in the root level. So you can do whatever is your requirement and just do that particular policy in the top level that will protect your account. Now let's look at another restrictive type of policy, which is session policy. This is an inline policy which user passes in that particular session when they assume the role. The session policy limits the total permissions granted by the resource-based policy and the identity-based policy. So what does that mean? Like, we will create some policy and then pass that policy while assuming a role. And whatever is in that particular policy, we can have maximum permission is that one. It could be either inline policy, like we can create a policy file and we can pass that, or it could be a managed policy, we can pass the ARN. But the effective permission will be whatever is inside that particular session policy. And it will be intersection with resource-based and identity-based. Now, say I have created a session and after that I got an ARN. Once I get the ARN, I can update that ARN to the resource. In that case, the resource, I will get the resource-based policy outside the session-based policy. Does that make sense? Because we are updating the resource policy with the new ARN we got. That's how we got the permission here. When we have session-based policy, permission boundary, and identity-based policy, in that case, the effective permission will be the intersection of all of them three. Now let's do a demo of session-based policy. For that, I have written one policy. In this policy, I'm just giving list and get object from this particular bucket, and I have UFO there. So I'll try to assume that session and try to grab that particular object from there. So I'm in that particular folder. Now I'm trying to execute this policy. So here I'm mentioning this session policy.json file as a policy, but I'm using this full access role where I have full access of this account. Once I assume this, now I should not have full access. I should have access only what is maximum in the session policy. So let me go there, update those tokens. Session. So I will use this 3 token for assuming that particular session. Now let's see what permission I will try to first list this particular bucket where I have given permission. Okay, I have permission. Now, if you see this folder, there is only this 3 file. Now I'm trying to copy something as UFO copy. Now, see is there. There it is. This is the real picture. Okay. Now try to describe this EC2 instance in US East 1. Describe. I'm not authorized for that. Because this session policy is restricting me only to these 2 particular permission. Now let's go back and continue. So let's look at the effective policy. When I have identity-based policy and resource-based policy, the effective permission is union of all of them. I'm talking about one single account. Now, inside my account, when I have permission boundary and identity-based policy, then the effective policy is the intersection. When I have organization's SCP and identity-based policy, the effective permission is the intersection. And when I have resource-based policy, permission boundary, and identity-based policy, so we'll get everything from resource-based policy and intersection of permission boundary and identity-based policy. When we have organization SCP, permission boundary, and identity-based policy, effective policy will be this intersection. Now let's look at the policy evaluation logic. So this is what I was talking about, Ravi, before. So remember at very beginning, I was showing how authentication and authorization works in AWS account. So once AWS has that request context, based on that, it collects all the policy document. And once it gets all the document, it first check if there is any deny statement for this particular action for this resource. That is called explicit deny. If there is any explicit deny, then it will be denied. That is the first thing. Now, all the deny is out of picture if there is no deny. We are going to next step if there is no deny. Now, it will check is the principal's account a member of organization with an applicable SCP. So who is calling that? If that principal is not member of organization, then this SCP is not applicable if the resource belongs to some other account. Does that make sense, Ravi? This is what I was talking about. So it will check if that particular principal is a part of an organization and that has applicable policy. Then if that particular SCP is allowing this particular service and action or not. If it is not allowing, means it is denied. But if SCP is allowing, then it will go and check if there is any resource-based policy for this particular resource. So if there is any resource-based policy and that resource-based policy is allowing, then we are allowed. We don't need to check other policy. This is for one particular account, but if it is for cross account, it's a little bit different than this. So next, if it is not allowed in resource-based policy, then it will go to check if there is a permission boundary attached to this particular user or role, this particular principal. If there is a permission boundary attached, then the permission need to be there. Otherwise, if the permission is not there, then it is denied. But permission is there or there is no permission boundary, it will go to the next step to check with the session policy. So is this principle a session assumed using a policy? In that case, does that particular policy allow this action or not? If it is not allowing, then it is denied. But if it is allowing or there is no session-based policy, in that case, it will go to next step, which is identity-based policy check. It will check, does this principle have any identity-based policies? If it does not, it is denied. But if it has some identity-based policies, and is there an allow for this particular resource for this action? If it is, then it will be allowed, otherwise it will be implicitly denied. Now, if you look at it very carefully, there are two allow. One is resource-based, another is identity-based, because they are only permissive policies. And all other are restrictive policies. If there is any deny, then there is no question. That is, at the very beginning, we have thrown that out. But if there is no allow in those policies, we are implicitly denying. That's how we are restricted. If you know this picture, it will be very easy for you to understand like what is going on in IAM. I hope I'm able to give some insight about that. Now let's look at cross-account access. So I have two accounts. One account has Lambda and role, two Lambda and two different role, and then those Lambda want to access this bucket. How we will give access to this? We can just simply create one access key and secret and give that. Yeah, will it work? Yeah, it will, because that is the way to get access to another account. But is that a secure way? Definitely not, because that is a long-term access key and secret, and we should not do that. This is not a good practice. Instead, we should create either resource-based policy and give permission to this specific role for the exact action in this bucket, or so in that way we will get access. Or otherwise, we can create a role in this account and then give permission to this role. Then we will give access, we will give a trust policy. So there is another type of policy. In a particular role, we have permissions there we attached. And sorry, I'll just go back and show you guys that. So let me go back to a role. So in this role, this permissions is where we attach all those policies, but there is another tab which is trust policy, where we trust another account or another service or a role. So in this trust policy, we can give that particular Lambda role as access for that. In that way, that Lambda will get access. So we'll assume this role and then we'll be able to get access. Now let's go back and show you some cross account by assuming role. Okay. Let me use a role. Okay, so let me go to another account, B account. I was working everything on A account, this Firefox and Chrome, they are A account. Now I'm going to another account, B account. In this account, I have logged in as B2 admin. I have a role here, NashJS B2 account access. So here I have given full access for S3, and I have given a trust policy where I am trusting a different account. Look at the account number is different. So this is my A account number, and I have given that policy. And let's look at the policy. I have mentioned root, means I'm giving access to the account. Now this account will manage who will assume this role. So let's go back to this account now. And I have given access to this particular user, A1 dev. I have given access that you can assume this particular role from another account, NashJS B2 account access. So now if I come back here, A1 dev, and another thing, in console, when I'm assuming those roles, I cannot do a role chaining here. I always have the permission as this user, and then from there, if I have the permission for assuming another role, then only I can go to that. And I lose my user permission and go back to this particular role. Now, when I assume this B account role, now I am in the B account, and I have full access for this S3 here, because we have given full access. We can just download, open any file. We can delete anything we want. Let's do this. Okay, so we have full access there. Now, let's go back to our presentation. So we have seen by assuming role, we can do that. Same thing we can do with CLI or API. We can do the similar thing by giving permission and then just assume that. Now let's look at cross-account access by giving a resource-based policy. So how we will do that? In B account resource in S3, we will add some permission for A account's username. So let's go back there. Yeah, also one more thing here. Also, we will attach another policy which will deny this account to put some object in my B account without giving full access. Why we will do that? If another account is giving some object in my account and I don't have access, I may not able to delete or do some other operation with that object. So I always need full access whatever is in my account. So let's go back to a demo. So right now I am in B account. I'm in B account. Let's go to S3. Yes. Yeah, I won't be able to get full access. That is why they have to give full access to the on. So I'm in this particular bucket and let's see, let's go to permission and attach some permission here. So I already attached this permission that I showed in the PPT. And in the A account, also I need to give some permission here. Even if I have the resource-based policy in B account, the user is in A account. So the user must have some S3 permission. So let me check what permission this user has in A account. Okay. So for cross-account access, I have added this particular permission that, okay, you can do these operations for this particular bucket. Now let's go to a demo. Where I will try to list this object from this bucket. Okay, I'm able to do that. Now, I'm able to download also. Now I'm trying to put one object without giving that SEL, that bucket owner, full access. It should deny me, but when I'm giving that access to the bucket owner, it will allow me to upload. Now let's go back there in B account, and now we will have UFO back. So you can see that we got permission. This particular user who kept this object has full permission, as well as this bucket owner also got full permission. Now let's go back to the presentation. So now when to use which type of policy? We have learned about various different types of policies. We have this particular scenario, allow a specific role from account 111 to have full access to particular S3 bucket folder of another account. Which kind of policy we should use? I'll choose the resource-based policy and IAM policy because they are cross-account, so we need both. Then don't allow to create a new user for any of your account. So why you will do that? Say you are using your identity manager, you are using like say your accounts federated user pool, like say you already have IAM users, you want to use them and log into your AWS console. In that case, you don't want to create any new user, but you want them to federate and log in. You can restrict them and don't let anyone to create an admin user or any other user. You can just attach this policy in service control policy. Then we already saw this. If we don't want to stop CloudTrail logging, we can just attach a policy in the root level in service control policy. Then it will stop anyone from stopping the CloudTrail or deleting that or updating. Then allow developers in your department to create role and pass that role to EC2 or Lambda. We need to give IAM policy to allow. because that is permissive policy. However, when we want to allow developer to create the role, but we want to restrict them in a particular boundary, in that case, we are going to use permission boundary, right? IAM policy and permission boundary. So now let's troubleshoot that policy error, authorization error. Remember when we tried to stop one EC2 instance, we got some weird error. So let's go back and try to do similar thing. I'm going to EC2. Okay, I'm A1 admin. Now I'm admin, so I should be able to stop this EC2 instance, right? Okay, I won't be able to stop this EC2 instance. There is a reason behind it. Okay. Let me show you in another one, then I will come back to that. Now, let me get full access to this account using this A1 MFA. I'm going to issue 2. So Ohio region is not supported. Virginia. Let me try to stop this instance from. So it is allowing me to stop here, but it was not allowing me to stop there. Now let me go back to admin and try to debug what is going on there. So this is already like stopped, but let me launch another one. Maybe that will be a better way. Try to launch something. So review launch, proceed without it. I should have saved that error at that time. Okay, so I'm able to launch also in this one. Now let me assume a different role where I will get error. So that particular role has all access. Now this role does not have access. If I go to issue 2, and try to launch an instance. So now we got this error. Let's see why we get this particular. So in order to debug this error, we have some tools. I am using this particular command, STS decode authorization message. That is one encoded message, and I'm trying to decode. And in order to decode, I need a permission. I'll show you that. So it gives me this particular output, which is not so readable, but I can copy that and go back here. Then I need to replace those with double quote. Replace all. This is a little bit lengthy process, but it ought when we have error and we don't know why it is happening. So I got that particular JSON, and let me first show you what we have in this particular role. If I go back to IAM, decode auth error, I have given full EC2 access. However, there are some other statement here. So this particular JSON document is telling allow is false and explicit deny is true. So there is one statement where statement ID is this. So this is how SID is handy. This SID is getting printed here where I have told that run instance is denied. So you can see this same SID here. So this is how it is getting denied. Now there is another way we can debug them. Policy simulator. So if I come to this one, you can see that it is by default assuming that role. And I need to add some permission in order to see those in policy simulator. So in policy simulator, if I go to the role and select that particular policy, then select issue to, I want to see some actions and want to simulate them. Then terminate instance and then run simulator. I can see that this run instance is denied here. And it gives me this show statement. If I click, it shows exactly which statement is causing this failure. So if you know how to decode your message or how to use policy simulator, in that case, you can very easily identify what is causing that particular problem. Now, in order to have this access, I added some permissions. Let me show you that quickly. So for auth error, I have added this policy simulator permission. This is required in order to show them in policy simulator. And for that particular user, when I decoded the message, I have used this permission, STS decode authorization message. That is how I got the permission. Now let's go back and move on. Now we have learned how to, we have learned about various policies, and now let's learn about least privilege. In this particular policy, you can see there is some problem. The action telling DynamoDB star and resource star means everything. We are giving all permission. This is not good. And if somehow someone get this particular permission in a role and able to get hold of that role, they can do anything with our table, with any table in this particular account. We should not do this. Instead, we should write, say, I have a Lambda for just creating some object in DynamoDB. We will just be put item role there, and we'll specify that account number and table name. Then if we have to update similar way, just give that permission what is required and give that specific table name over there. So that's how if we specify that exact resource and exact permission, we will achieve least privilege. And also in some case, if we need to like give particular condition, that will also help us. So never give any star. There will be some possibility that you need star, but try to avoid as much as possible. And revisit policies being used, take help of tools like Access Advisor. So you can use Access Advisor to see which service is being used recently by which role, and that will give you good idea that there are some excessive permission, you can just remove them. Then for Lambdas, try to use least privilege role and create role part function. You can use some plugins for that. Then tag-based access control, like, so suppose, say, you went to a shopping mall and you saw a really cool, like your favorite item, maybe a jacket or bag, something you saw. And then you are super happy. Then you went to billing counter and ultimately found out that there is no barcode, there is no tag. And you can understand the hassle. They are calling some other person to find the price. They are not able to find the price ultimately of that item, and you may need to leave that item there. So if tag is not there, this is not good at all. Same for AWS account, all the resources, try to tag if it is possible, so that the billing and other thing is easier for that account. Management will be more easier. Now, using tag, we can do access control. So how we can do, you know that we can add tag to principals like user and role. Also, we have tag for resources like EC2 instance or secret manager. Say I already have some existing secret manager that has some tags, and I have a user or role that has some tag. We can do a matching between them and see if this principal tag, principal means who is trying to access that, principal tag is matching with that resource tag. In that case, we will give access to get value from that, otherwise not. Also, we can do same thing with EC2. So that's why the admin was failing. So same thing for EC2, the resource tag and the principal tag need to match. And when we are creating a new resource, in that case, it will not be resource tag. In that case, we are giving a request for creating something new. So it is called a request tag. So if we just mastered this piece. This is very simple. We can write very effective policy, and we can minimize so many policies in very small number of policies, and those policies are reusable. Here is some example. This is the exact policy which was causing deny for admin to stop that instance. So the admin tag and that EC2 tag was not matching, project tag. I have attached this particular policy in my SCP. That's why it was denying. And here is another one. So previous one was resource tag and principal tag matching, and for existing resource. And this one we are creating a new resource. For run instance, we are telling this request tag need to match with this principal tag. Otherwise, we will not let to launch EC2 instance. Now let's revisit. Once we know the context of action, like the request context when someone is trying to access something, then AWS collect all the policy document and see if there is any explicit deny, then it is denied. If there is no explicit deny, it will go to the next step and check if that particular principal's account, a member of organization SCP, then we'll apply. If there is an SCP policy which is allowing, then we will go to the next step if it is not implicitly denied. If SCP policy is allowing, it will go and check with the resource-based policy. If it is allowing, then we are good. But if there is no resource-based policy or not allowed, then we will go to the next one. And we will go and check if there is any permission boundary for the principal. If there, we will check if permission is there. Permission is not there, then it is denied. But if permission boundary is not there or permission is there, we'll go to the next step. Session-based policy. If this particular principal is session assumed policy, then is there an allow in that policy? If not, it will be denied. But if it is not session-based policy or allow is there, we'll go and check with identity-based policy. If there is an identity policy for this principal and there is allow, it will be allowed. Otherwise, it will be implicitly. So there are some reference I have used. And Q&A. Any questions you guys have, you can ask me.